So you may recall the inverse function from Math 151. You had 1 or 2 sections on it. And just a quick reminder of what an inverse function is, that if you have a regular function, and imagine you put some value into that, and then out comes some value. So we commonly call this the input, the output. Now an inverse function, commonly denoted by the -1 in the superscript there, by the function name, an inverse function will take this output B and output A. So again, if you put something in this function, it gets some number out. If you take this same number and put it into the inverse function will output A again. Now imagine a regular old function has some domain and range at x and y. Now an inverse function has a domain that's y and x. In other words, if you have your regular old function, the inverse function switches the domain and the range. It just switches them. That's what an inverse function does. The domain of a function becomes the range of the inverse, and the range of the function becomes the domain of the inverse. Sometimes we say the input and the output switch. That's an inverse function. Now, something else about the inverse functions is if you have a regular old function, and if you stick its inverse into it, so you're going to stick the inverse into the function itself. And when you do that, you will always get x, or whatever the variable name is. Now, same is true with the inverse function. If you take the inverse function and you put the original function in, so we're going to take the original function and put it into the inverse, we also get x, or whatever the input variable name is. So just some reminders, some quick review on the inverse function and its properties. So for us, we're going to focus on sine, cosine, and tangent. And these inverse functions are written sine, cosine, and tangent, except they now have the -1 in the superscript. Sometimes these are also called arc. So instead of saying -1, some people will say like arc sine, or arc cosine, or arc tangent. That means the same thing as this. We're going to use the -1 terminology, though. So these are the inverse trig functions we're going to be dealing with. So what does this mean? Well, let's take something. Sine of theta equals 1/2. Now, if you've been memorizing those tables of important angles, you should already know what theta is here. Sine of what angle gets you 1/2? Now, to solve this mathematically, we would actually take the inverse sine of both sides. So notice I'm going to take the inverse sine of both sides. Now, on the left, this is where the property of inverse functions come into play, because when you take the function and stick it into the inverse, that answer will always be whatever the variable letter is. In this case, theta. And then we have this solution. This is the answer to theta. Theta is the inverse sine of a half. In other words, the inverse function outputs the angle. So sine of what angle has a half? Well, 30 degrees. And how do I know this? Well, this is part of the table of values you're supposed to remember, that sine of pi over 6 is a half, which means the inverse sine of a half is pi over 6. How about cosine of a half? Well, to solve this mathematically, we would take the inverse cosine of both sides. Now, why do we do that? We do that because of what happens on the left. Because of the property of inverse functions, when you put the function into its inverse, you will always get the variable. And that's how we get our solution for theta. Theta is the inverse cosine of a half. Now, you could type this into your calculator. However, these are part of the table of values you should be remembering. What angle gives a cosine of a half? And that angle is 60 degrees. So this table I'm talking about is this one right here. These are the all-important angles and numbers you should be burning into your brain. And let's just take some examples here. Like the inverse tangent of 0. So we look at tangent, and we see here's the 0. What angle corresponds to tangent 0? Well, 0. How about the inverse tangent of square root of 3 over 3? Well, we'll look. Here's square root of 3 over 3. The inverse tangent is going to output the angle for that result, pi over 6. Or how about the inverse tangent of 1? Well, we're looking at our table. We will see where 1 is. And the inverse tangent outputs the angle for that number, 45 degrees. So question 1. What is the inverse cosine of square root of 2 over 2? So we look for the output. Here's the output, square root of 2 over 2 for cosine. The inverse function will output the angle. And so that angle is 45 degrees. There's something else that's important about inverse functions. And here's the sine function. And recall the vertical line test. Now, the vertical line test was if you can draw a straight line and that straight line only crosses the function once, then it is a function. The vertical line test. Now, for there to be an inverse function, not all functions have an inverse function. For there to be an inverse function, our function has to also pass a horizontal line test. If a horizontal line crosses the function more than once, then there is no inverse. And so we have a problem with sine here. Because sine fails a horizontal line test, which means there's no inverse for sine. And so what we have to do is we have to truncate sine and only look at a little slice of it. And the slice that we're going to look at is from minus pi over 2 to pi over 2. If we choose this slice, then the function will pass a vertical and horizontal line test. So if we choose this domain restriction, then we can define an inverse sine function. And this is what we do. We constrict the domain of sine to minus pi over 2 to pi over 2, which means the inverse sine will only output angles between these numbers. And the same is true with cosine. Cosine also fails a horizontal line test. And so to fix that, we have to restrict cosine. And we restrict cosine from 0 to pi. The inverse cosine will only output angles between 0 and pi. Same with tangent. Tangent also fails a horizontal line test, which means as it stands now, there's no inverse. So we have to restrict the domain. And just to say again, why is there no inverse? Because recall that for a function to be a function, it can only output one value per input. In other words, if I put one number in, I can only get one number out. If you put one number in and get two numbers out, then that's no longer a function. And this is what happens with these repeating functions, is if we would just flip these around without any restriction, then we would put one number into the inverse and we would get infinitely many numbers out. And that's useless. It's useless to get infinitely many numbers out. And so for this to be useful, we have to restrict the domain so that we don't get infinitely many numbers as our result. And the domain we restrict for tangent is from minus pi over 2 to pi over 2. And this domain restriction will then make tangent a one-to-one function. So if you recall back to Math 151, a one-to-one function is guaranteed to have an inverse. A one-to-one function is a function that passes the vertical and horizontal line test. So here's where we're at. That's important to put into your brain. This table is important to put in your brain. What's also important to put there are the domain restrictions for the inverse trig functions. If you don't know the domain restrictions, then you will get wrong answers, because you will occasionally give an angle that is outside of this domain restriction. And that would be a wrong answer then. So you have to also burn into your brain these domain restrictions for the inverse functions. So let's check some out. So we have the inverse sine of sine. Now recall the properties of inverse functions. In the inverse functions say when you put the function into its inverse, this will always give you the input. However, 5 pi over 6 is not in our domain restriction, which means the inverse sine is not going to output 5 pi over 6. It has to output an angle between minus 90 degrees and 90 degrees. So how do we figure out what that angle is? Well, we have to go to the reference angle. So 5 pi over 6, this angle here. And we can see then that the reference angle is pi over 6. Now recall that sine is y over r, and our reference angle has a positive y component, which means sine of 5 pi over 6 is the exact same as sine pi over 6. There's no sign change. And now check out what happens. Now that we've used the reference angle, the inverse sine of sine will just give us that pi over 6. And pi over 6 is in our restricted domain. And pi over 6 is our answer. Check out another one. Inverse tangent of tangent. So we could just right off the bat say, using properties of inverse functions, that this is 3 pi over 4. But we can't say that because the inverse tangent function is domain restricted from minus 90 to positive 90. And 3 pi over 4 is greater than 90 degrees. So our answer is not going to be 3 pi over 4. So how do we figure it out? Go into a reference angle. So here's our 3 pi over 4 angle, which means our reference angle then is pi over 4. Now recall that tangent is y over x. And looking at our reference angle, we have a positive y, but we have a negative x. And so what this means is that tangent 3 pi over 4, remember, 3 pi over 4 gives the same magnitude as the reference angle. The only thing we have to worry about here is the sign change. And we can see there's going to be a sign change here because the x component is negative. So tangent pi over 4 is negative of tangent 3 pi over 4. And so we can replace that using reference angles. And we know tangent pi over 4. It's right on our table here. Pi over 4 is 45 degrees. So tangent 45 degrees is 1. So we can replace that in there. And so finally, we're looking for the inverse tangent of minus 1. And how are we going to do that? Well, since tangent and inverse tangent are odd functions, remember an odd function, if you put the negative in an odd function, that's the same thing as putting a positive into an odd function, but then multiplying by a negative value. So we're going to use the property of odd functions to deal with that minus sign, bring it outside the inverse tangent. And now we can look at our table to see what tangent 1 is. So we'll look for tangent 1. Here it is on our table. And now the inverse tangent will output that angle, 45 degrees. Pi over 4. And then our minus sign is still sitting in front. And that's our answer. That is within the domain restriction of the inverse tangent function. So question 2. What does this equal? Well, if we put a function into its inverse, we will always get that argument out. And if this argument is within the domain restriction, then that's our answer. We don't need to go to reference angles. And 2 pi over 3 is within the domain restriction. And 2 pi over 3 is the answer. Check out another one. So some of these are going to require a right triangle to solve. And here's an example of that. And how are you going to know when to use a right triangle? Well, when you're dealing with a number that's not on our table. So this number 4/5 is not on our table. So we're not going to be able to use our table here, which means we're going to have to go to the right triangle. Now, we could have used the right triangle with the previous problems, actually. But since we do have this table, it was easier to use the table. And here's our right triangle. And remember what this 4/5 means for sine. The 4 is the opposite, and the 5 is the hypotenuse. And so we're going to label that on our right triangle. Here's our angle. So the opposite is 4, and the hypotenuse is 5. And we will also use Pythagorean theorem to get the remaining leg here, which is 3. Once we have our completed right triangle, we can answer every trig question, every trig function question here. So remember, this expression right here, this expression is this angle. This expression equals this angle. So this is like saying cosine theta. And now we can just look at our right triangle to see what cosine theta is. Cosine is the adjacent over hypotenuse. Let's check out another one. Minus 1/4, not on our table. Going to have to go to a right triangle. Now notice cosine, there's a minus here. And remember, cosine is x over r. So if there's a minus sign here, that means x must be minus. So x is minus this way, which means we're going to have two possibilities for our right triangles. Could be in quadrant 2 or quadrant 3. And our angle is either to here or to here. How do we know which angle? We go to the domain restrictions. We know it can't be this longer angle because that's not within 0 to pi. So it must be this angle that's in quadrant 2. And to get the other leg, we use Pythagorean theorem. And now that we have our right triangle completed, we can answer all the trig questions. So remember what the inverse gives us. The inverse gives us the angle. So this is like saying, what is tangent theta? This expression here is just a complicated way of expressing theta. And we can look at our right triangle and now identify what theta is. Because we know tangent is y over x. And now if we look at our right triangle, we can see y is square root of 15 and x is minus 1. And so we get our answer of minus square root of 15. So in summary, what's going to be valuable for this section? This table again. This table is going to be valuable all semester actually, but you're going to be using it a lot in this section. What's new are the inverse trig functions. We're only going to use sine, cosine, and tangent here. But what's especially important are the domain restrictions, so you understand when this function is valid. Outside of these restrictions, this is no longer a function. So it has to be within these domain restrictions. And finally, something else that's useful that we've talked about already are even and odd functions. Sine is odd, cosine's even, tangent is odd. Now it also turns out that the inverse of sine is also odd, and the inverse of tangent is also odd. Now the inverse of cosine is neither. The inverse of cosine is neither even nor odd. It's none of them. So sine and its inverse are odd. Tangent and its inverse are odd. Only cosine is even, and the inverse cosine is none of that. It's neither. And that is this lecture.